All right, let's go. Let's do this. Share my screen. All right. We want presentation. All right, Noah, can you see that?
Yeah, I can see it.
All right, perfect, man. So this is session 2 of ACT Science, and we're going to cover research summaries. I believe you guys talked about graphs in the last section, so I'm going to move on to research summaries. Here we go. All right, so first, just a bit of a review, what we already know about the ACT Science portion of the test. We know it's 40 questions in 35 minutes. So it's going to give us about 5 to 6 minutes per passage to make it through, which is in 6 to 7 passages, there are going to be 3 types. So Coach Reese last week, he did an awesome job talking about data representation. You're going to see some pieces of that in what we talk about today with research summary. We're going to spend some time there. This is going to take you back to your basics of all your science classes, looking at how we research, experimental design, the data sets, your tables, graphs, all of that kind of information there, the methodologies, independent, dependent variables, all of that information is going to come back into play. So really, when you hit a research summary section, you want to tap back into the basics of any science class that you've ever been in, especially your experimental design skills. And then the last one is conflicting viewpoints, which we won't touch on today, but it'll be coming soon. But just to keep in mind with conflicting viewpoints, just to kind of touch on it, you're going to see some passage where there are 2 different views about the same set of information. And so we'll get more into that as we pass on into our other ACT sections. All right. So as far as the directions are concerned, you're going to generally see the same thing you see every time you get to a section. You have 7 different types of passages to complete. Each passage, which could include charts, graphs, written information, is followed by 5 or 6 or 7 questions. Pick the correct answer to each question and fill in the correct bubble on your answer document. You can look back at the passages as many times as you need. Calculators are not permitted on this portion of the test. Even though you're going to see a lot of numbers, you won't need a calculator. And I'll probably allude to this a little bit in another section of this PowerPoint. But there's not a lot of math or science involved at all. A lot of what you're going to look for in the form of answers is already in the passage. So you're really not going to need a calculator per se in this. But main thing I want to hit on in the directions is if you have 5 or 6 minutes per section, make yourself familiar with the directions of every section, because time you waste reading the directions in this test is time you don't have to be reading a passage or interpreting data or answering questions. So with any section on the ACT, make yourself familiar with the directions before you get there. Okay, I know that's contrary to what we always teach as teachers. You know, we always say, read the instructions, read the instructions. No, in form of ACT or in terms of the ACT, you need to know the instructions for each section before you get to it, so you don't waste your time reading those. All right, ACT Science, the basics are here. Biology, Earth and space science, chemistry, and physics are going to be what you're going to see on ACT, your 4 or 5 basic areas of science. Okay, Big thing here is, and I really won't get into this unless we talk about the general test itself for a session. But even in these sections, it's all the basics of these units. The other thing to keep in mind is there is some pre-existing knowledge that you do need to know in biology, earth, space, science, chemistry, physics, etc. But again, like I said, most of the answers you're going to find within the passage. So even if science was not your greatest subject, if you read well, you understand passages well, you're still going to be fine. The ACT science test is a science reasoning test, which goes back to what I just said. Most of the questions are going to be answered by the information they present you with. You're not going to have to spend a great deal of your time trying to remember everything you learned in your science classes. It's going to be very intuitive, and you're going to answer questions based on reasoning from what they give you. Okay, there are 3 different types of passages. Of course, data representation, 3 passages with about 5 questions each. Your research summary passages, there's 3 of those with 6 questions each. And then you have conflicting viewpoints, 1 passage with 7 questions, okay? So let's go through and talk about our strategies for mastery. The next few slides are going to talk generally, and let me say this, you can ask me a question at any point, stop me at any point, have me clarify, it's not a problem. When you have ACT science strategies for mastery, the science test is not a test about science. I want to kind of drill that home to you because a lot of people go in to the science portion feeling like, I don't know a lot about science, I don't like science, and they go into the section already defeated. Do understand that this is primarily not about science, but it's a reasoning test that's going to be associated with the data that they give you. So you're going to be making assumptions and answers and interpretations of the data that they give you, okay, and of the information that they give you. So don't feel intimidated by the science piece. Do all your easy passages first. Many of the students actually find data representation questions easiest. However, I just want to make a point that whatever you feel out of all of these practice tests that you do, whatever you feel like comes easiest to you in this section, do that first, okay? It's already mapped out for you. Find those sections, knock those out first in the science section. So if you're good at data representation, knock that out. If you're good at the conflicting views, knock that out. If you're good, whatever you like, do that first, okay? Then that's gonna allow you to knock those out in less than 5 or 6 minutes. Then you've got time to really spend on the sections that seem harder to you. Every answer you need is printed in the passage. So the thing to keep in mind is that when you go in to read these sections in science, don't spend your time tripping over words you never heard before, reading the passage 2 or 3 times. Don't do that. Read it, skim it, find important main ideas, find information in graphs and charts, and then go back to your questions. And then you can use your passage or your graphs like anchors. You can go to the answer and say, okay, I remember seeing that here. I remember seeing that in this chart or in this graph. Or they may allude to a certain graph name or title. You can look back to those sections. Be familiar with interpolation, extrapolation, and scientific notation. So we're talking about how we actually notate in science, how we look at particular graphs and data relationships. Okay, you talked a lot about that in the last session. So I won't really spend a whole lot of time on that. I'm gonna go on. Analyze all key aspects of graphs and tables. If there was ever an important part that I would want to spend time on is that piece right there. Analyze all key aspects of graphs and tables. During the summer session with the 9th and 10th graders, I actually did a lesson on analyzing graphs and data. And one of the big things that we kind of ignore is that we hone in on the actual expression of the data, but we skip the basics like our X and Y axis. Our X and Y axis are going to give us our independent and dependent variables. Sometimes we skip the title completely. And so if I ask you to allude back to or refer back to a particular table or graph, if you don't know which title it is, you may waste time that you need searching for which graph you need. Sometimes there is sub information that has been listed in a graph. If you're skipping over that information or missing graphs completely, there are several questions that you're going to need information for that you just don't have. Okay. All right. Then let's see here. Look closely at trends and direct inverse relationships. That's the other piece I wanted to hit. You know, we talk about graphs and data, but data has relationships. Sometimes you'll see direct relationships or positive relationship. That means as the independent variable is increasing in a particular graph or data set, your dependent variable is going to increase. For example, maybe it might be watering a plant and looking at plant growth. So if my independent variable is me increasing the amount of water that I'm going to give a plant, and then the dependent variable is that the plant starts to grow larger, then that's a positive or direct relationship. Okay. Inverse relationships have to do with the opposite. If my independent variable increases, my dependent variable is going to decrease. So that same scenario, the more I water the plant, if I overwater it, the plant may die or it may shrink, you know. So if I'm seeing an adverse relationship, that's an inverse relationship in my data set. Okay, so there may be particular trends in data that they want you to analyze. Always answer like studies and experiments consecutively. A lot of times you'll have like questions together that have to do with a particular experiment. That's more towards your conflicting views. They may ask you 2 or 3 questions about one view or 1 or 2 about another. Try to make sure that you answer those questions together because you've already got that particular information and data on your mind, and you won't confuse it with something else you may be reading inside of that passage. Identify main points of difference in conflicting views. Okay, all that's saying is when you get to your conflicting viewpoints, if there are points that are standing out, hence conflict, if there are points that are standing out, make reference to that because that's probably something that's going to come up in a question for conflicting views. That's the whole point of the question of the data set. All right, moving on. All right, need to give you a practical tip as well. Keep your energy and your grit turned up, okay? It's kind of good that we're doing this section today after we've done a whole day of school because the fact of the matter is that you've already sat through 3 other sections, and the writers of the test, the makers of the test, they already know you're tired, and they're going to take advantage of that. They're going to take advantage of trip ups like, I don't even want to read this graph. I don't want to look at the data table set. I'm going to skip this part. They're going to take advantage of that. And so it may not be hard questions that you're missing at this point. It could be questions that we're missing because we've gotten tired, you know, and our instincts are low at that moment. So make sure you do something that's going to keep your energy and your grit turned up. You know, I recommend if you're a breakfast eater in the morning, eat your good breakfast before you go take the test. Nothing too heavy that's going to make you sleepy. So be careful with that. Eat some energy-rich foods. You know, take a moment and breathe. You know, get that oxygen flowing to your brain, okay? So that you can think clearly. Get your fingers stretched. You know, if they allow you to stand before you start the section, stand up, stretch, you know, kind of get that oxygen flowing throughout your body, get you some gum or a mint, you know, get you some sugar intake, you know, anything you can do to keep your energy going, to keep yourself turned up and ready to hit this last section, okay? Now, the section that we're going to talk about today is the research summary passages. And the way I've kind of set it up is I'm going to tell you more about each of the sections and kind of give some examples of what's there. And then I'll give the exit ticket, which is actually a passage and questions, okay? So super, super easy to do. And then I'll be open for questions from you guys as well. So research summary passages, 3 to 4 passages are going to be there requiring you to understand, evaluate, analyze, and interpret the design, execution, and results of one or more experiments, okay? Basic way to kind of figure that out is when you hit your focus, you're going to look for words like experiment, study of, anything, like that has experiment and data sets are definitely, going to be your research summary passages. You want to focus on your charts, graphs, tables, and interpreting that information, okay? Do not skip that because the whole point of the experiment is to get the research data. So you definitely cannot skip your data tables and graphs because that's going to be the most important portion of the passage. And I cannot tell you how many times people just skip those, end up wasting time or can't find information because they're looking back through the passage for the answer and it's just not there, okay? And it's in the graph or chart. So you should skim that passage with a focus on the charts, the graphs, the tables, and then jump straight into the questions, okay? So here's the format. Here's what it looks like. You're going to get a description of one or more related experiments and studies by a researcher or scientist. The descriptions are going to include the design, the procedure, and the results of an experiment or study, okay? The results, though, are going to also be displayed in some table or graph. So the skills that you were using in the data section is the same thing you're going to use here in conjunction with your experimental design skills. They're going to ask you about your understanding. They're going to ask you to evaluate and interpret the experimental design and the procedures that have been given, okay? Or they're going to ask you in some format how to analyze results. More often than not, that's what you're going to see, an analysis of the data results. So, skip one, here we go. So how do we attack this research summary section? How do we make ourselves successful at the at conquering this research summary section? The first thing you need to do is identify the purpose and the method in that section. The purpose is why the scientist is actually conducting this experiment or design in the first place, okay? So once you're reading that passage, that's the first thing that's probably going to jump out to you. You want to underline that as you read it. Big question you are answering is, what are they trying to find out? What results are they trying to get to? That's the whole reason why we do an experiment in the first place. We want to get some results, some information, some research answer, okay? The verbs that you're going to be looking for is to study, to examine, to find out, anything along those lines. The method is the description that comes after the purpose. And so basically you'll have a few lines or maybe a few points in that section, that are about how the scientists came about their answers, how they reach their results and findings. You want to make sure that you notice any similarities and differences in the experiments if they give you one or more. Okay, sometimes you will see different trials, and you may see one set of data that has a particular trend in that set for the initial trial, and then you see another set has a different trend for its trial, and so forth. So make sure if you see more than one trial or more than one data set, that you make sure you are paying attention to the similarities and differences between those experiments, because it's not just there for naught. There is a purpose for the information there. Did any variables change between the experiments? So if there is more than one trial, did they change a variable? And that's important because we use control variables in science. So if my variable changes, then I need to notice if my dependent variable is going to change as well. So if my independent variable changes, I need to notice if my dependent variable is changing as well. All right, and just again, reminder, if y'all have any questions at any point or need me to clarify or repeat, just let me know. The next thing we need to do is understand the variables. Every experiment has independent and dependent variables, every one of them, okay? The independent variable is the variable that the scientist, control. That's how I always remember it. And independent always starts with I. Independent is the variable that I control. I can control the temperature. I can control the pressure. I control the time. I control the date. It is the variable that you see the scientist manipulating in the experiment every time, okay? The dependent variable depends on or responds to the independent variable. So every time you see the scientist make a change in the variable, you're looking for what the scientist then observes in response to that change, okay? So let's look at the example below. We see that the scientist increases heat, then the rate of the enzymatic reaction increases. Okay, in that example, what portion of that is the independent variable?
The second portion.
Okay, why do you think it's the second portion?
Because after he changed the independent variable, the rate of the enzymatic reaction increased.
Okay, so the dependent variable is the second portion because the scientist is controlling the heat. So the scientist controlling the heat is the independent variable, and then the rate of the enzymatic reaction is the dependent variable because it's responding to the increase in heat. So those of us who know, our basic bio, we know that heat can actually be a catalyst to speed up a chemical reaction. If I heat a protein or heat an enzyme, that rate of reaction is going to increase. However, if I heat it up too much, I can actually destroy that protein or enzyme, and it just stops working, and the rate of reaction actually decreases at that point. So yes, you're correct. First portion, scientists increases the heat is the independent variable. The dependent variable is the rate of the enzymatic reaction increasing. Then the third thing is to look for answers beyond the passage, okay? Everything that they give you is fair game. One of the big things that people do, and you've heard me say this over and over and over again, is that in these passages, they skip the data and figures, they skip the tables, they skip the graphs, and they keep going. And ACT loves to ask questions about data. They are going to ask you that because one of the common rookie mistakes is to skip these figures, tables, and graphs. So you want to also make sure you read the titles of the table so that you know where to find your answers. If you're going back to actually read your answers, then your answers may say, look at data table 1, or look at the table about the mountain incline. If you've never read the tables, then you got to go figure out which table you're going to. But if you have read those sections, you're automatically going to know where to go find those answers or where you've seen that information before, rather than trying to read back through the passage to find it. Make sure that you analyze the graphs. So analyzing the graph, you know, are basics, like looking at every part of the graph. You know where the title is. You know that your x-axis, is going to have your independent variable there. Your y-axis is going to have your dependent variable there. You're going to actually look at the trends in the data, seeing if there's if there are any trends like direct, indirect responses, any cyclic representations of the data, anything like that that you can use to your advantage. What you want to do is skim the passage, read and interpret the data, and then go to your questions and then search for your answers, okay? Don't waste a lot of time reading so far into it, deep into it. Skim the passage, find the important information about the purpose, about the methods. Go on to your data set, find those trends, analyze those graphs, and then jump to your answers and use what you've learned in the passage as hooks to find your answers. So here's the reminders that I have, okay, before I release you to the practice. The research summary reminder is this. Number one, identify the purpose and the method for that experiment, okay? Two, understand your variables. Understand what they're using as the independent variable, what they're using as the dependent variable, and remember that everything that they give you is fair game. So not just the text in the passage, but the graphs and the tables also. Here's a big reminder. The answers are in the passage and beyond. So don't feel like every answer is going to come off the top of your head. It's there in the passage, or it is there in the graphs and the tables. Don't be intimidated by words you can't pronounce. They love to do that to trip you up, and you spend 30 seconds trying to say a word that you've never seen before, and they don't even ask you a question about it. Okay? Just, sound it out, move on. Okay? Vocabulary that you need is usually easily defined in the passage. If it's a term that you're going to need, they're going to give you a definition. They're going to give you some kind of context clue, some information that you need. A lot of times we waste time trying to analyze words and terms that the writers are not even paying any attention to. So don't waste your time getting tripped up in those areas. All right. So that's all that I have for the lesson portion. Okay. I tried to make sure that I wasn't too long. And so I guess I went long enough this time. But I just want you guys to kind of see what that looks like in the sections and kind of what the general portions of the science tests are going to look like. Okay. So I have what I'm going to send you in the chat. Okay. Let me give you the exit ticket. I have it right here. And Noah, did you have any questions?
No, I'm good.
Okay. I'm going to send you the link for the exit ticket. And then I'm going to send you the passage for it. Here we go. All right. All right. So the first thing is the file for the ACT practice. If you click that PDF, it's actually the reading of the passage. Okay. And then you have the table 1 and table 2. and then you can actually use that information to answer the 5 questions that are given in the uh, Google form in the link that I just sent. So you can knock that out. I'm going to be on right now, so if you have any questions for me while you do that, you can let me know once you've knocked it out. If you don't have any more questions, you can go.
Okay, cool.
All right.
I think I only got one link in the chat. I don't think I got the passage.
Okay, it doesn't show a file, the ACT science practice.
Cause I'm in the exit ticket, but I don't see a
Oh
passage or anything.
no. So go back to the chat. It's right above the link. Should have been a file that said the ACT practice something.
Yeah, I only see the link in the chat, not a file.
Okay, let me try to send it again. Okay, so I just sent it again.
Okay.
Did it come through?
No, it's not popping up in the chat. It might because it is a file.
I'll tell you what. Here's what I'll do. I'll make it a Google Doc. Let's do that. That'll make it easier. File upload. Here we go. Just learn something new about technology every day. Let's see. We want to share this. Get a link. Copy link. All right. Use that link, Noah, to go to the PDF.
Okay, I see it now.
Okay. There you go. Uh-huh. No, it should give you a score at the end too.
Okay, I'll let you know. I'm wrapping up. I got a couple of questions left.
Okay, you good. You good. No rush.
Okay, I finished.
All right, let me see what you got. Let's see. Okay. Okay. All right. All right. So you want to talk about your answers real quick?
Yeah, we can.
Okay, cool. Let's use the rest of our time to do that. Then we hop out. So first of all, you didn't do too bad. From some of the answers I'm looking at, you did all right. I'm gonna show you my screen here if I can figure this out again. There we go. All right. So what I did was I pulled this straight from the ACT website. Okay. And so I'm going to compare what you have to what the answers were. All right. So basically what this is was paper chromatography. Okay. It really doesn't matter if you can say chromatography or not. But we instantly know this is an experimental design, because we've got pictures showing where everything's moving, how it's set up in the beaker, all that kind of stuff, right? So we can use this to identify metal ions in wastewater. Drop of sample solution is placed on filter paper. The bottom of the paper is set in a solvent that travels up the paper. The solvent carries the ions up the paper. Some ions move faster and therefore farther than others, resulting in separation as they move up the paper. That line right there is important because it tells you how to understand the information.
Yeah.
The farther that the dot moves, the faster it moves. Okay, there's a question that does come up about that. Resulting in separation as they move up the paper. The paper is dried, then stained, causing the ions to appear as colored spots. The RF values are calculated for each spot. So that's the total linear distance traveled divided by the total linear distance traveled by the solvent. Okay, so Table 1 shows RF values for 5 ions. Table 2 shows RF values from 3 different samples of wastewater. Okay, so here's the thing to understand. Table 1 is going to be like our control groups. It's going to tell us what we ought to expect if I give you a random sample. So in Table 1, we see the different metals. We see their molar mass, which is irrelevant information. They ask us absolutely nothing about the molar mass. All we're working with in these questions is the distance that we travel. And we can see here, what relationship do you see in this data for the distance?
The decimals just moved over.
Say that again.
The decimals just moved over.
Okay. Okay.
Distance.
Okay, so you said between the distance travel and the RF.
Yeah.
Okay. What about as you look at the data for just the distance travel? Do you see anything happening with the data going from nickel to mercury?
Highest to lowest. I mean, lowest to highest.
Correct. So they've got this already listed for us in a particular order. And so how would you say, if you thought about what the passage said, would you say lowest to highest, or would you say slowest to fastest?
Lowest to fastest.
Right. So you can use your passage to analyze the data based on what you just saw.
Yeah.
Okay. So you just saw them say the faster that it moves, or the longer that it travels, the farther that it travels, the faster it is. So we're definitely moving from slowest to fastest here. Our RF values are definitely similar. And then we see that they have ranked a color with each one. So that's definitely something I can use to my advantage if I'm not good with numbers. Okay.
Yeah.
All right. So table 1 was adapted from Thomas McCullough, CSC, and Maris Curley, and so forth. That's all data information. Okay. Then we see data 2 here. It says, note, samples contain only the metal ions listed in table 1. So definitely that's helping us to understand there's not some random piece of data we got to pull out of the sky. We just need to match up table 2 to table 1. All right, so first question says, the information in tables 1 and 2 supports the conclusion that sample 3 contains what? Okay, so let's see. You were here. There we go. All right. So your answer was D, and you're correct. Okay. And so here's the whole thing here. If we look at the sample, we see pink, yellow, brown, black, and we got an RF of 0.95 here on that brown, black. Now we had 2 brown, blacks earlier, but if we look, brown, black here is mercury, our pink is the nickel, and then our yellow is the cadmium. And so all we've got to do is easily, we didn't even have to go back to the past, just straight from the data, D is there. So, all right, so we missed the second question. Let's read that. Based on the information in tables 1 and 2, one can conclude that sample 2 contains what? You said 1 metal only. Okay, here's why it's two metals. Let's look. Number one, we know that all of these responses here, these are all metals.
Yeah.
Nickel, cobalt, copper, cadmium, mercury, right? So when we look at, this says basic information table 1 and 2, we conclude that sample 2, boom, sample 2, brown, black, brown, black. Now, we might say 1 because brown, black is the same, but we got to go back to table 1. We had 2 brown, blacks in the data table. But the RFs are different. The
Yeah.
RF for cobalt is 0.35. RF for mercury is 0.95. So this has got to be 2 different metals. You see that?
Yeah.
Okay. So that's why the answer is 2 here instead of 1.
Okay.
Does that make sense?
Yeah, for sure.
Okay. Number 3 you got right. Based on the information in table 1, which of the following list the metals in order from the fastest and slowest? You definitely got that right. And that goes back to what we said earlier. We've listed them from slowest to fastest already, so all we needed to do was look at the metals backwards from mercury to nickel. All right. Then, based on the information in table 2, which of the following figures best illustrates the appearance of the filter paper after sample 1 was analyzed? Okay, you chose H. Tell me what was going through your mind when you chose this.
So I had skipped that one, and I picked that one. That was my last one I answered.
Uh-huh.
So I don't want to say I really technically guessed, but I wasn't really deciphering it to answer it correctly. Like, I didn't spend as much time as the rest of them.
I got you. Okay, so let me show you the strategy here. So anytime they show you a picture like this, it's always something they showed you before.
Yeah.
Okay, so let's go back to the first diagram. See that solvent?
Okay.
That's where our starting line is. The drop of the sample solution is there. And then we've got our filter paper where we're traveling up, right? So let's think in terms of what we see here as far as distances are concerned. Nickel would be closest to the bottom. Mercury would be closer to the top, right?
Okay.
Can we agree on that?
Yeah.
Okay, so then when we look, it says we're looking now at sample 1. It wants to know what would that sample look like after we analyzed it. So that's basically after we kind of put it through the process. So let's go to sample 1. Sample 1 has blue and yellow. So if we look further down, the paper would be pink. We go up a little more, we see brown, black, and then blue and yellow would be closer to the top, and then we would leave room for mercury at the top. So if we picture that in our mind and look at these distances, this H couldn't be it because it would have been our smallest metal, the smallest distance traveled. So the closest it's going to be is E because we still got a little bit of room for mercury to hit at the top. And then we're close to each other near the top, and we've got room for our other 3 metals at the bottom. Does that make sense?
Yeah, that makes sense.
Okay. So what they're making you do is analyze that as a picture in your mind. Now, what you could have done is, if you were working on paper, you could have just drew it out, just scribble, scrabble in your mind what that paper would have looked like on there. If you're a visual person, you don't have to be Picasso, but you just scratch it out. Put an X, this is where mercury would be, this is where the other, and then you'd be able to kind of see what's left. Or you can just scratch in your, with what's already drawn here in your book. There's no rule against that because your answer is going to go with the key. Does that make sense?
Yeah, that makes sense.
All right, our last one, number 5. It says, based on the information in table 1, the best identify a metal ion using paper chromatography, one should know the what? And you chose distance to solvent travel and spot color of the ion only. All right. So here's where we got to choose the best answer. Okay. And I get that. I'm going to click on D, and we're going to talk about what they said. It said D is not the best answer. Spot color can be used to restrict the range of options, used to identify metal ion. However, some metals, such as cobalt and mercury, have the same spot color, okay? Which is the brown-black. To determine the identity of the brown-black spot, one needs to know the RF of the spot. So if we look at distance travel and the spot color of the ion only, that would be it. And so we need the distance traveled. That's the RF value.
Okay.
Does that make sense?
Yeah, that makes sense.
So right here, RF value here, and the spot color. Making sense?
My bad.
Oh, you good. You good. What kind of dog you got?
Hold on. My mom at the door. Hold on.
Oh, okay.
All right, I'm back.
All right, you good. What kind of dog you got?
It's a Jack Russell Terrier. It's a little small dog.
Oh, okay. What do they make about us? All right, you good, man. So I just want to say this. Based on what I saw in your answers, man, you're really good at seeing trends in data. You're good at seeing the pattern. What we want to work on is the interpretation of the data. What is it trying to tell me? How can I actually analyze and interpret that data myself? Like in that number 4 question with the drawing, that's another way for you to actually interpret the data that's been given to you. So
Okay.
data analysis and interpretation is definitely what you want to work on in your science classes or in your science practice. But you readily see trends like nobody's been. So you're probably like me. I like patterns. I like things to move a certain way, and I notice when something is out of order. So like if they would have stuck one, like if they'd have put Mercury in the middle, I'd have noticed that right off. It's like, why is this not in order? That would have bothered me. And so if you know that about yourself, then when you practice, the thing you want to look at is, okay, how can I analyze this data? How can I further get more information out of this data? And so you want to look for those questions that can help you do that. And then if you can knock that out, man, you can increase your score.
Okay, cool. Thank you.
All right. Proud of you, man. Glad you joined us tonight. Have a good one.
All right, you too.
All right, now. Bye-bye.